and it's a very relevant topic on our current situation, like how AI can be explored for different teaching, learning, and research perspective. So, for as I got an opportunity to deliver a talk on this particular FTP, I have chosen a but very very keen topic: leveraging machine learning for scientific discovery and innovation. So, the question I want to ask you before starting the session is, can machines help us make new scientific discoveries? Because we humans are actually very keen or very known for finding new discoveries and inventing things and all, right? So similar in a similar fashion, can machines help us to find new scientific discoveries or to get new inventions? So the overall idea of this particular talk is how this can be possible, how the machines or the machine intelligence can be effectively utilized or can be leveraged to make new scientific discoveries, and what all things are actually currently happening in the space of this scientific discoveries and innovations. Okay. So the overall idea is we always find this, we always perform the scientific discoveries with human intuitions, right? So this human intuitions can be collaborated with machine intelligence. Then it will amplify that intuitions, and we can actually find, or we can actually come up with new scientific discoveries much faster and more much uh, effective, right? So how this is possible? So as an introduction to this, see, we can actually see or we can actually view this AI and machine learning as a new lens of science, right? Because whenever there is a big transformation happening in our technology and scientific space, these are all happening with new devices or new equipments that can see the world in a very in another perspective, right? In 1608, the telescope actually made us to view the world outside our Earth, and we know what is galaxies, what is beyond our Earth. Like all these things are actually explored with the lens of telescope by Galileo. And after that, the microscope, the another lens that made us to view what we are not able to view in a very particular way, uh, like how the life is actually happening, right? How what are the internal or what are the secrets behind the life, or how the microscopic and the nano level things are actually happening. These things are actually made possible with the help of microscopes. And after few years, we are actually very uh, very useful, or we are actually very bounded to a particular device called computing devices, which made a big transformation in our day-to-day life, right? And now it now this is the age of artificial intelligence and machine learning, and it can be also viewed as a lens for viewing the science in another perspective, right? So how this is possible? How this AI and machine learning can be utilized for this kind of scientific discoveries? So before getting into that, can someone tell me what is your idea about artificial intelligence? Anyone from the past few days? Can someone unmute and tell me what is your idea about artificial intelligence? Be interactive, as I'm not seeing your faces. I just want to get an idea about whether you are perceiving it in the right way or not. Anyone? Anyone? Any suggestions on what is your idea about artificial intelligence? Anybody? Don't be hesitant, please.
It will make our work simple.
It will make our work simple. Okay, that is actually one perspective, or we can actually quickly mark it as a application of artificial intelligence. So use of artificial. So particularly what is artificial intelligence? It can be viewed as a branch of computer science that focus on including intelligence into machines and systems. Okay, that is a major point. That is, we are trying to induce intelligence into machines and systems. And how this is possible? We are actually leveraging data and algorithms. Okay, we are actually using data and algorithms to induce a kind of intelligence to machines and systems. And what is the purpose of inducing such kind of intelligence, or what is the need of making a machine intelligent? It is nothing but to make a machine or a system enabled to reason, learn, make decisions, optimize, and to even generate creative contents. Right? So we can simply say that machine learning is nothing but it is the technology that try to make a system think like a human. And what are the recipes for that? To make a system think like a human, we need two major things. The first one is data, and the next one is algorithms, right? And what is the purpose of making a system intelligent? It is nothing but, see, we have to make a system reason, learn, decision making, optimize, and to even generate contents, right? So this is the major objective of making a system intelligent, or we can say this is the objective of artificial intelligence, right? How a machine can be uh, a machine can be converted, or a machine can be enabled with the thinking process happening in human. Okay, so based on this particular definition, I can say, see, within machine learning, we are actually utilizing different kind of learning techniques, right? Or intelligence making strategies, right? And among these strategies, machine learning is actually one of the major subdomain of artificial intelligence, or I can say it's a kind of strategy I can rely upon for making a system intelligent. Speech systems, computer vision, natural language processing, expert system, planning and optimization, robotics. Each of them are actually subdomains of artificial intelligence, and these categories or these classifications made based on the strategy we are depending upon for making intelligence, as well as the the modality of data we are depending upon. See, in speech systems, we are actually using audio and sound for making intelligence, right? And for computer vision, we are using images, visual data and information for making intelligence. And in the case of natural language processing, we are using text. The expert system, we are depicting the expertise of a human expert. Planning and optimization, we use different evolutionary computing and mathematical models for optimization. And robotics are the physical realization of artificial intelligence, right? So even though we are having this much subdomains in artificial intelligence, I should say machine learning is actually one of the prominent subdomain in it. Why it is the prominent subdomain? Because we have to use machine learning along with all these things. That is, we have to collaborate machine learning with speech, vision, NLP, expertise, or robotics. Everywhere we can see the influence of machine learning. That is why we are actually saying that the machine learning, the domain of machine learning is actually dominating artificial intelligence. Or I could say, whatever you are now experiencing as artificial intelligence is actually coming under what machine learning itself. Or nowadays we can say machine learning is somewhat equivalent to artificial intelligence. So that is why I put the topic as machine learning rather than AI. Because whenever whatever we are now doing is actually coming under what machine learning. So what is machine learning and what is the idea of machine learning? See, if I open up a puzzle for you, see, if 1 is mapped to 1, 2 is mapped to 4, 3 is mapped to 9, 4 is mapped to 16, and 5 is mapped to 25. What is the mapping of 10? Can anybody tell the answer? What is the mapping of 10?
Squares of the
Yeah,
numbers.
10 is mapped to 100, right?
Nice.
Yes. So the thing is, you are able to answer this question as 100, right? But still, I was not revealed the relationship between the first number and second number, right? So how did it possible? That is exactly happening in machine learning. So what happened in your brain? when I give examples that can be technically called as data, when I give data to you, your brain is actually going through the data, right? And what is happening by going through? We are analyzing the data, and after analyzing the data, as an outcome of that analysis, what you got? You got a particular pattern that connects the input and output, right? That input and output is connected with a pattern, and you are able to identify that pattern, right? Or you are able to learn that pattern. And with that pattern, you are actually making a prediction that the turn is mapped to 100, right? So exactly this is happening in machine learning. You will be having a data with you, and there will be an algorithm. Our brain is the algorithm. The algorithm will consume the data, and it will finally find out a pattern. And technically, that pattern is called as a model. That model is a decision rule or something like that. Okay. Then with that model, okay, with that model, if you give a new input, the output for that new input will be predicted based on the decision rule or the model we have. Okay, hope this is clear for you, right? Okay, so machine learning is nothing but it is a branch of artificial intelligence that focus on a particular strategy called learn from experience. Okay, learn from experience. And what is happening in this machine learning, or what is happening, or how this is possible, how we can actually learn from experience? We will be having a data. That data will be given into a machine learning algorithm. That machine learning algorithm is capable of analyzing the data, and after analyzing the data, it will come up with a new pattern which is hidden in the data, and that hidden pattern is actually called as a model. Okay, model. And with that model, what will happen? We can actually apply a new data and predict the output, or we can map the output for that particular data. Hope this is clear for you, right? Any doubts?
Yes.
Yes. And when to use machine learning? Can we use machine learning for every problem? See, as I said, the example for 1 is mapped to 1, 2 is mapped to 4, 3 is mapped to 9, 4 is mapped to 16, and 5 is mapped to 25. And you will be able to tell me what is the output of 10, that is 100, right? But if I give the samples like 1 is mapped to 1, 2 is mapped to 4, 3 is mapped to 8.9, 4 is mapped to 16.2, 5 is mapped to 25, what will be the output of 10? Is it possible to tell that as 100? No, right? Why it is not possible? Because now the relationship between the first value and the second value is having some kind of uncertainty, right? So the machine learning is well suited for problems with uncertainty. Because if the relationship is crisp, there is no need of machine learning. Do you really need machine learning for calculating the billing process happening in a supermarket? If you know the price of each item, if you know how much quantity it is purchased, if you know what all products purchased, do you have any uncertainty in calculating the total bill?
No, sir.
No. So machine learning is not useful for such kind of use cases. Machine learning is useful only when there is an uncertain relationship between input and output, right? Input and output. And what do you mean by this uncertain relationship? The input and the output is not mapped with a crisp relationship. Okay, not mapped with a crisp equation or a what empirical equation, something like that. Okay, so if I ask you, is it possible to map an equation to predict the uh, weather conditions of tomorrow with the today's weather condition? Is it possible? Do you have any kind of equations to find out the temperature of tomorrow from today's temperature?
I think no.
No. Why? Because there is an uncertainty involved in it, right? So for such kind of predictions, we can actually make use of machine learning. The goal place prediction, right? Or even phase detection. What is the uncertainty in phase detection? What is the uncertainty in phase detection? Can you just think about it? What is the uncertainty in phase detection? See, if you have trained a model with your face, okay, if you have trained a model with your face, see, if you simply make up some, do some makeup, or if you simply change your haircut, or if you simply wear a spec, what will happen? Is it same as that of the previous one which is used for training? No, right? So there is
Yes.
also a kind of uncertainty happen, but still, what is the next point? Even though in that uncertainty, the problem should have a hidden pattern in it, right? So in the previous example itself, I couldn't say the second number is the square of first number, right? But I could say the second number is somewhere nearer to the square of first number, right? That is what we are calling as a hidden pattern, right? So the hidden pattern should also be there to apply machine learning for solving it, and that hidden pattern can be generalized. Should be able to generalize using approximation, and that approximation should work with minimum error on unseen data. This is the cases where we can apply machine learning for solving or handling a problem. Hope it is clear, right?
Yes.
Where to use machine learning? The problem should have an uncertainty in it. It should have a hidden pattern present in it. And we must be able to approximate that hidden pattern to a generalization. And that generalization should work with minimum unseen data. Right? And this is happening in two phases. The first phase is called as training. And after training, you will get a model. And that model will be used to predict the outputs for unseen data. And we should get minimum error on that unseen data. So that is what we are expecting from a machine learning model. And usually this machine learning techniques are classified into supervised learning, unsupervised learning, and reinforcement learning. So I'm not explaining much on this supervised, unsupervised, and reinforcement learning, even though simply if you're having an input output pair, if you know the input as well as the output, then to find the relationship between input and output, we can make use of supervised learning techniques, right? So there should be a label, true label should be there for mapping the inputs to a particular output, right? And if you don't have any output associated with our data, like you have only data, mere data, and you don't know any kind of mapping that is defined for that input, what can we learn from it? It can be nothing but we can learn the relationship between the data, right? We can actually explore the relationship between the data itself. So that is what happening in unsupervised learning technique. And reinforcement learning is a kind of machine learning technique which is based on rewards. Okay, reward based optimization learning is actually called as reinforcement learning. Okay, so finally, from this explanation, I just want to make you understand that, see, in the training phase, we have the data and we are applying that data into a machine learning algorithm, and you will get a machine learning model, right? You will get a machine learning model. And in the inference part, you will be having the model. You will apply new data on this model and you will get the predicted output. Hope it is clear, right?
Yes.
Yeah. So from data to discovery. So what we are actually doing is we always do the scientific discovery using experiments, right? Or we have to set a hypothesis, then we will perform experiments based on the hypothesis on the data, and we will analyze the results we are getting. And if it is not getting satisfied, we will redefine the hypothesis. And likewise, this is a loop, right? So it will take much effort and much time to arrive at a particular hypothesis based on the data, right? But in ML augmented loop, what is happening is we have the data initially. Okay, we have the data and we have a model, and from that model, we are trying to find out a hypothesis using automated experiments. Okay, automated experiments. What is happening in what has happened in the previous example itself? See, if I give you 1 is mapped to 1, 2 is mapped to 4, 5 is mapped to 25, 10 is mapped to 100. To find out the relationship between x and y, the first and second variable, what we will do is first you will set a hypothesis y equal to x, and you will try the experiments and obtain the result. Okay, what will happen? Y equal to x is not applicable for all this data, right? Then you again try with another relationship y is equal to 2x. Then again we will do the experiment, and again on seeing the result is not matching with the result, right? Again we will try with another relationship y is equal to x plus 1, right? That is also not getting satisfied. And finally, we will try with y is equal to x square, right? And with that relationship, all the data is getting satisfied, and as a part of analysis, we will updo the hypothesis. That is the traditional loop. But here, what happening in machine learning augmented lookers, on giving the data itself, our algorithms are initially itself able to identify the relationship as y is equal to x square, right? So it will help us to manage the time as well as the effort we are putting for such a discovery is and actually comparatively less, right? So that is the advantage. Okay, so how ML fits in